Hello everyone and welcome back to another video. Today we'll be taking a look at the British Informatics Olympiad 2011 paper, and we'll take a look at the third question. So I'll let you have a quick read of the question first before I explain what the question is as well as the solution. Okay, now let's jump to the whiteboard and quickly explain the solution of the question. So pretty much for a single digit number to be an upside down number, it has to be 5, since 5 is the first digit and the last digit, and therefore the sum of the first and the last digit is equal to 10, which is our requirement, and there is no second digit or second last digit because it's a single digit number. And now let's consider like 28 or 37. These are a few examples of even digits, two digits, which has an even length obviously, and which are upside down numbers. So the first and the last both add up to 10 in both of these cases. Now, this question, pretty much, one thing which you have to spot is that for any odd length upside down number, the middle digit must be 5. Since for an odd length, let's say the length is n of a particular number, then the n minus 1 divided by 2 character from the front will also be the n minus 1, will also be the same as that particular character from the back. And the only way that one particular character plus itself to equal 10, let's just say for any c plus itself to equal 10, the only way for that to be possible is if 2c equals 10, which means c equals 5. Okay? There's like no other character which satisfies this condition. So what we've identified so far is that if the length of the upside down number is odd, then we have to have 5 as the middle character. And now another thing which we've established, sorry, I'm just trying to get rid of this, is that for any even length number, there is no middle character, hence we have no need for the middle character to be a 5. And now, one thing which is also worth noting is that let's just consider all the possible 2-digit upside down numbers: 1, 9, 2, 8, etc., all the way to 91. Okay. And now, if we consider all the possible odd ones, or odd upside down numbers, odd length upside down numbers of length 3. So it will basically go 1, 5, 9, 5 has to be the middle one, 2, 5, 8, so on, till 9, 5, 1. There aren't any other possible ones. So if you notice that there are only 9 possible ones for 2 digits, and 9 also for 3 digits as well. Since the middle one is fixed, and then otherwise it would be all pretty much identical to the one above, except we insert a 5 in the middle of it. And now let's consider all 4-digit upside down numbers. So we can basically have 1 and 9 as the first and last characters, 2 and 8 as the first and last characters, and we continue this pattern until we get 9, and then 2 more characters, and 1 is the final one. Okay? Now, we can pretty much have 2 characters in the middle of each of these numbers, right? And now those 2 characters can be any of 1, 9, 2, 8, etc., 9, 1. Which, if you notice, is pretty much any of these, like stars, characters. Any of them can go inside here. And since we have 9 different arrangements of 1, 9, 2, 8, all the way till 9, each of those 9 have star different arrangements, which is 9. So that basically means that for 4 digits, there are 81 different upside down numbers. Okay? And now, if we go to 5 digits, you might be spotting myself in front of it, but if not, don't worry, we'll make it very clear. For 5 digits, it's exactly the same as the one above, except there's a 5 inserted in the middle. So it would pretty much be identical, except a 5, okay? Hence there would also be 81. And now, if we consider 6 digits, it's everything inside the 4 digits, but with 2 extra digits inserted. Hence it would be 81 times 9, which is 729. Different possible arrangements. Okay? And then, therefore, we can pretty much derive some sort of nth term. Since for the second and third length, there are 9. Fourth and fifth length, there are 81. Sixth and seventh, 729. So, if you notice, the nth term will basically be. Okay, I'll just group them maybe a bit more clearly. For this, it will be 1, since the only 1 digit possible is 5. For this, it will be 9. For this, it will be 81. So then these can basically be rewritten as powers of 9. 9 to the 0, 9 to the 1, and 9 to the 2. Hence, the nth term will basically be, for 2 and 3, we want 1. 4 and 5, we want 2. So then we get n, where n is the length of the upside down number. And then we basically do this, absolute division by 2. So what this basically means is n divided by 2, and we're not concerned with any decimals. So it's integer division by 2. So for example, like let's say 7 divided by 2 divided by 2 would give 3 remainder 1. However, we ignore the remainder, hence it'll just give 3. So 7, 2 will equal 3. Hence, our formula is n divided by 2. Since 3 divided by 2 will give 1, 5 divided by 2 will give 2, etc. Hence, for the nth length upside down number, it will have n divided by 2 possible numbers. Now, why is this important? Let's just quickly go to the big picture real quick. So, let's say we want like the 100th upside down number. We basically know that it won't have length 1, since there's only like one possible upside down number with length 1. It won't have length 2, since there are 9 possible ones. It won't have length 3, since there are also 9 possible ones. It will have length 4, since 81 possible ones. Hence, the 100th one will pretty much be the 100 minus 9 plus 9 plus 1, which is 19. So it will be the 81st character within the 4-digit numbers, which means it will be the very last upside down number with length 4. Now, the reason why I added 19 is because if we group all the upside down numbers in order, all of these numbers come before, all of the numbers with a lower length than 4 come before length 4 upside down numbers. Hence, when calculating the total, we need to basically disregard all of these, and we only focus in on this, and then we generate the 81th number within here. And now, now that we have an algorithm for generating what length a particular upside down number is, let's just see how we can actually generate the actual upside down number. So let's just say that we want to generate the 15th number with length 4. Okay. So we know that length 4 pretty much constitutes in 81 different numbers, which means that there will be 9 different numbers which start with 1 and then end with 9, having some possible 2-digit numbers over here. We also know that there will be a further 9 which have 2 followed by 8, and then further 9, 3, 7, and etc. etc. This basically means that 1/9 of all the numbers, of these numbers, 1/9 of all of them are in each of these particular cases, between 1 and 9, 2 and 8, etc. etc. Which means 15th, it can't fall on the first 9, since 81 divided by 9 is less than 15. However, we know that it must fall inside here, since 81 divided by 9 times 2, which are all the numbers before 2, 8, and including 2, 8, is greater than 15. Hence we know that the 15th possible upside down number of length 4 must have 2 as the first one, 8 as the last one. And now here's where the real beauty of the question comes in. So now that we know that it's the 15th number falls within this particular arrangement, we want to know out of those 15, since it can fall from anywhere from 9 to 18, 15 falls as the sixth one between this range. Since remember, as starting with 2 and ending with 8, there are 9 possible ones. So then we want the sixth out of them. So then this problem is equivalent to finding the sixth upside down number of length 2. Okay, and the sixth possible upside down number of length 2, we can then solve this with the exact same algorithm which we used to solve our original one. And now this recursive bit of code is exactly how we will end up solving the question. Okay, and now that's pretty much it. There's one small catch, since we just considered even length upside down numbers, but let's say we wanted the third upside down number of length 3. It's actually equivalent, since we basically fix 5 as the middle one, and then we just treat this as length 2. And that's pretty much how we'll go about solving this question. Now let's have a quick look at the code for solving this. Okay, so pretty much this bit of code, this bit of code just outlines what length, how many possible numbers there are for each length upside down number. So let's say of length 3, there will be, as we discussed earlier, 3 divided by 2 to the power of 9, or 9 to the power of 3 divided by 2, different upside down numbers. This just does that. And the way we do that is we could use the power of 9 thing, or we can just multiply the previous by 9 if it's odd, or if it's even, then we pretty much just append whatever was there earlier. Since remember, indexing starts from 0, hence the first index would be like the length 2, hence it would be the same as the one. It will be 9 times the one before it. So this array will then end up with 1, 9, 9, 81, 81, 721, 729, etc. And now we basically accept the nth number as the input, since we want the nth upside down number. And this pretty much iterates through the array, and this finds out what length the nth upside down number has to be, just how we did earlier. So digits is the variable which we have stored, and that will then have, let's say, length 3. If we're looking for like the 80th upside down number, it will be length 3. And now we subtract 1. The reason why we do this, I'll explain a bit later. And this odd is a Boolean. It basically self-explanatory. It says whether the number is odd or not. And I is basically an index, which we will come to later. And R is basically just our final output message of all the of the upside down number. And we initialize them to all 0, since we don't know what the upside down number will be. And count is pretty much the a variable which I'll explain later. Actually, that's probably a bit clearer if I explain a bit later. So I'll explain what this does, but we pretty much iterate through this particular sequence until we are finished. And increment is the steps in which we go up. So remember, as I was saying earlier on the whiteboard, 1/9 of all numbers fall within the first range. First range being starting with 1, ending with 9. Another 9th fall under starting with 2, ending with 8, etc., etc. Hence, that's basically increment. Num is all the possible ones of that particular length, and increment is 1/9 of all of them. So just dividing by 9. Now, int is basically the index I'll come to what the index does slightly later. And the nth number is the input number minus I divided by increment. Okay. So pretty much this code is recursive. Hence, what this does is it divides. It basically finds which index within the particular length of digits our number falls into. Okay, so let's just say that our number is 100, and yeah, that will basically mean that I is 9, since it will become clearer after we explain this line. But then let's just say I is 9. Then we do 100 minus 9. Okay, I think I'll explain what it is. I is basically all the possible numbers which came before that number. So let's just say it's 100. So then the numbers which come before it would be 1, 9, and 9. Since 1 would be all the 1 length ones, 9 would be all the 2 length ones, and second 9 would be all the 3 length ones. So then we want to subtract that particular number, so 100 minus 19, divided by increment. Exactly how we did like a few minutes ago on the whiteboard. And after we divide it by the increment, that is the index of which the first character will be in our particular output array. So now we basically just add all the possible elements before that, because let's say we're doing 100. So at the 100, we basically need to add all the ones before 100, so like the 70th, 71st, all the way to like 99th. And then after that, num becomes increment, since this is basically like a loop. So in the next loop, since how this works is that we'll fill the first character and the last character first, then we'll go to the second and the second last, and then for the next loop, we'll basically be having a factor of 9 less than our initial one. Hence, num will be increment, since that'll be a factor of 9 less than the original num. And our count and our digits 1 minus count. This is basically the first character and the last character would basically be int plus 1 and 9 minus int. Okay? And now we increment the count. The reason why we do this is because in our first loop, we obviously have the first character, but in the second loop we're gonna have the second character, in the third loop we're gonna have the third character, etc., etc. Okay, and now let me just walk through this again, because you only will really understand it after understanding what it does the first time, since it's kind of iteratively defined. So then again, increment is the values of the increments divided by 9, since they all fall under 1/9 of each of the categories. Int is all the previous, int is basically the index of the particular number. I is all the previous ones. Num is the next number, which will be the current increment value. And this arg fills up the first and last, or the nth from the first position and nth from the last position, upside down numbers. And then we increment the count. And now, if it's odd, then the middle character, we just set it to a 5. And then finally, we just end up printing. I know that was a lot to take in, it wasn't an easy question, but let's just see whether our code works. So let's just go to the question and see on the sample test cases. Okay, let's just do it on, sorry, this is question number 2. Let's just test it on 14659, for example. And as you can see, 987654321, if we go back to our code. And if we go back to the question, this is indeed the correct answer. And now, if we go to the next, maybe let's just test on the final test case. It basically gives us the string 137327. And now let's just go back to the question. they are indeed the same. So, as you can see, our code does indeed work. And now, that's pretty much it for this video. I really hope you enjoyed. Hopefully you didn't find it too challenging. It was a quite difficult question, but hopefully you learned something new. And if you enjoyed the video, please be sure to leave a like and subscribe. It would be very much appreciated. And I hope to see you in another video. Thank you very much for watching.